Hello everyone and welcome back to this course on aluminium based alloys and metal matrix composites. So in the previous class we have talked about pure aluminium and different properties of pure aluminium. So let us continue and see the other aspects of aluminium and its alloys. So we have seen that there are different kinds of impurities in aluminium and they adversely affect many of the properties, and therefore it is important to remove the impurities from aluminium when it is being processed. Okay. So these impurities are commonly removed when the aluminium is in molten state, and one of the major ways of removing the impurities is by fluxing, where you use some kind of fluxing agents which will react with these impurities and form a dross which floats onto the surface of the molten metal and can be simply removed, and as it is removed, along with that the impurities will also be removed. So using fluxing agents such as sodium chloride or potassium chloride, many of the impurities can be removed, and in fact this kind of fluxing agents can also remove oxide inclusions. Then if there is dissolved gas, as I said before, that will lead to defects like porosity and blowholes, etc. in the castings. And hydrogen has considerable amount of solubility in aluminium, and therefore aluminium is prone to hydrogen dissolution, and therefore this has to be removed in order to make sure that this does not lead to defects in the castings. So removal of hydrogen can be done by the following ways. One can use vacuum to get rid of the dissolved hydrogen, and here you basically make use of the Sievert's law. Which essentially talks about the concentration of the dissolved gas and the partial pressure of the gas, and it is given by an expression like this, where CD is the concentration of the dissolved gas and PG is the partial pressure of the gas, and K is the equilibrium constant. For a diatomic gas such as nitrogen, which can dissociate like this, K will be given as which you can see from this particular transformation here, okay, where nitrogen is present with a particular partial pressure Pg, and this is being dissolved as atomic nitrogen, and that is why you have this square over here for this 2n. So the K is given by this particular expression. Then other ways of removing the dissolved gas is by purging the molten metal with an inert gas such as argon. So here when you pass the inert gas into the molten metal, it will basically form bubbles, and this hydrogen gas which is dissolved in the metal will get attached to these bubbles, and as these bubbles come out from the molten metal, the dissolved gas will also go out. So that's the concept which is used here. And these bubbles can be also generated by using purging tablets. So instead of using a gas, some kind of compounds can be also used which will dissociate at that temperature at the melting point of aluminium and produce high amount of gas, and as the gas is evolved during this dissociation, it will generate bubbles like how the gas purging does, and along with those bubbles the dissolved gas will come out, okay. So compounds such as hexachloroethane or C2Cl6 is used to do this job. So this is basically a blue color compound which are available as tablets or pellets. So these are simply added by taking this tablet and putting them into the molten metal, and as I said, when they dissociate in that temperature, they will generate a lot of gas and bubbles will form, and along with the bubbles the dissolved gas will come out. And even after doing these things, there could be still some more impurity present or left behind in the molten metal. So before it is poured into the molds, it is necessary to remove this, and therefore a filtration process can be used to filter out the leftover impurities such as inclusions and things like that. So in fact this is particularly useful for the solid impurities which are present in the molten metal. So a filter can be used. So this is basically passing the molten metal through a filter which will arrest these solid impurities which are present in the molten metal, okay. So pass the molten metal through a filter which is basically made of a porous refractory material. Right, and as I said, this will arrest the solid impurities, and a clean metal will be poured into the molds. Okay, and other kind of filters are also available. Such as fiberglass filter, tabular alumina filter, and ceramic foam filter. Foams, as you know, have lot of porosity, so this pores will actually act like a screen and arrest the solid inclusions present in the molten metal. And all these, of course, have to be made with a material whose melting point is much higher compared to aluminium, right? That is quite obvious, because here you are actually passing the molten aluminium through this filters, so it has to be stable at that temperature, at the melting point of aluminium, right? So these are the different ways by which the impurities can be removed from aluminium. Okay, so depending on the extent of the removal, you can obtain different kind of purity levels in aluminium. Commercially pure aluminium we have already talked about before, which will have about 99.5 to 99.79% aluminium. Okay, so this is CP aluminium or commercially pure aluminium. If you need higher purity aluminium than this, then you have to remove all those impurities efficiently during processing the aluminium, and depending on what level of impurities you have after processing, you will have different kinds of aluminium in terms of the purity, such as high purity aluminium, which has a purity of more than this. That means it is from 99.8 to 99.949. If it is beyond this, then the aluminium is known as super purity aluminium. So that is from 99.95% to 99.9959%. And if you want to go beyond that, then it would be extreme purity aluminium, having a purity of minimum 99.996 and up to 99.999. And beyond this is known as ultra purity or ultra pure aluminium. Which is greater than 99.999% aluminium. Okay. Right, so these are different grades of aluminium in terms of the purity. So depending on what is the purity level which is actually needed in the final product, the process of impurity removal can be accordingly carried out while the aluminium is being processed. Alright, so as I was mentioning while talking about the mechanical properties of pure aluminium, the properties are quite low, as you could see from this table over here, right? So therefore pure aluminium finds applications only in the areas where the strength does not really matter, or where you need a very high amount of ductility for it to be, malleable, so that it can be formed into different kinds of shapes. But there are many other applications, particularly the structural application of aluminium, where the strength is a factor and you need much higher strength compared to what you have in pure aluminium. Okay, and that's where the aluminium alloys come into picture, wherein you can add an alloying element and increase the strength significantly. Okay, so let us talk about what kinds of alloys you have and what are the major alloying elements in these alloys. Okay, so aluminium alloys can be broadly categorized into two categories. Wrought alloys and cast alloys. Wrought alloys means this has to be used in a particular form, such as a plate or a rod and so on. So that means it has to go through a secondary processing route to give it a shape like that, which is needed for a particular application. And cast alloys are the alloys which can be cast into the net shape or near net shape, okay, without the need for any further processing or extensive machining. So in order to specify the alloying element being present in a particular alloy, a designation is used which is known as the Aluminium Association Designation or AA designation. AA stands for Aluminium Association. So they have come up with a system or a designation through which you can identify what is or what are the major alloying elements in a particular alloy. Okay. For example, if it is 1XX, then it tells you that it is pure aluminium. Okay. And for the alloys where you have a particular alloying element, it will be by some other numbers like 2, 3, 4 and so on. So let us talk about the alloy designations for the wrought alloys. So designation is given by a set of digits from which you can identify the major alloying element or elements for that particular alloy. So as I said, 1XX, if it is like this, where it starts with 1, then there is no alloying elements. It is pure aluminium with minimum 99% aluminium. And for the alloys, it will start with some other digit such as 2 followed by 3 more digits. Okay. So this digit 2 that you have over here, this will indicate a particular alloying element. In this case, it is copper. Okay. So the 2000 series of aluminium alloys are basically aluminium copper alloys. Then you have the 3000 series 3XX. The major alloying element in this is manganese. In the 4000 series, it is silicon. In the 5 series, it is magnesium. In the 6000 series, it is magnesium and silicon. In 7000, the major alloying element is zinc, but you can also have some amount of magnesium. We have 2 more to go. 8000 is for the aluminium lithium alloy, so lithium is the major alloying element. There is one more, but this is actually unused. This 9000 series is not used so far. Okay, so these are the different designations or different grades of aluminium alloy, and as I said, from this digit you could actually identify the major alloying element or elements present in the material. Okay. So out of these alloys, some are heat treatable and some are not heat treatable. So this series 3, 4 and 5, these are non-heat treatable alloys. They cannot be heat treated to improve the strength because there is no precipitation that you can obtain for this kind of alloying elements. Okay. On the other hand, alloys of this series 2000, 6000, 7000 and 8000, these are heat treatable alloys. Because here you can obtain a precipitate by following a heat treatment sequence. So if you heat these alloys to a particular temperature and then quench it into water and follow it up with a heat treatment at a particular temperature, some kind of precipitates will form and that will give rise to the precipitation hardening, which we are going to talk about later on as part of the strengthening mechanism that we have here in the physical metallurgy of aluminium alloys. And the other thing that I would like to mention over here is that this particular series, the 4000 series, that is the aluminium silicon alloys, these are not really used in the wrought form. Rather, these are used as cast alloys. Okay, in fact, aluminium silicon alloys are the most widely used cast alloys, and this is something that we are going to talk about in the future classes when we talk about the different grades of cast alloys and things like that.
So before we wind up the lecture, let us take a summary.
So in this class today, we have learned about pure aluminium, and we have seen that pure aluminium contains certain impurities, and with regard to the impurities, we have talked about the sources, the types of impurities, and their effect on the different properties of aluminium, and then we have also discussed as to how to remove the impurities. Okay, and then we have seen that depending on the impurity level, there are different grades of pure aluminium. Commercially pure aluminium, for example, contains up to 99.79% aluminium, and there are higher purity grades which contain more than 99.79, that is more than equal to 99.8% of aluminium. Okay. Then we had a look at the mechanical properties of pure aluminium, and we have seen that the properties are in fact quite low, and therefore there is a need to improve the strength of aluminium, particularly for applications where a higher strength is needed. And there comes the alloys which possess much higher strength compared to aluminium. So in this particular class, we have talked about the alloy grades as to what are those different types of aluminium alloys which are in use. So these alloys are categorized into two broad categories, wrought and cast alloys. Wrought alloys are the ones which are formed into a particular kind of product, such as a rolled plate or sheet or a rod and things like that. And cast alloys are the ones which are cast into the final shape by the casting process itself. And the alloys are given a particular number by this alloy designation to identify the alloying element which is present in a particular alloy. 1000 series, for example, corresponds to pure aluminium, and the rest of the alloys that you see over here, the rest of the designations, that is 2000, 3000, 4000, 5000, 6000, 7 and 8000, they all belong to the aluminium alloys. Okay, so each of these digits that you have, the first digit will indicate the major alloying element or elements which are present in that particular alloy. For example, this 2000 series, the major alloying element is copper. In the 3000 series, it is manganese. In the 4000 series, it is silicon. In the 5000 series, it is magnesium. In the 6000 series, it is silicon and magnesium. In the 7000 series, it is zinc, and in the 8000 series, it is lithium. Okay, and we have also seen that some of these alloys are heat treatable and some of them are not. So among these, 2000, 6000, 7000 and 8000 series are heat treatable, because in these alloys there are alloying elements which can form a precipitate, and with the help of that the alloy can be precipitation hardened. Okay, right, so that is why these are called heat treatable alloys, because that precipitate can be formed by a heat treatment to improve the strength.
And with that, we come to the end of this lecture. Thank you for your attention.